leave that up for a few more seconds. All right, so let's say, for example, if you wanted to use the discriminant to determine the number and type of solutions. Okay, so let's say for problem A, we're going to make that x squared plus 2x plus 1 equals 0. Say for problem B, say 3x squared plus 2 equals 0. And let's say for problem C, 2x squared minus 7x minus 4 equals 0. Now you don't want to solve it. You just want to know how many solutions would you have if you decided to solve it. Okay, so mainly your discriminant is just b squared minus 4ac. Okay, so that's all you would need for this one. Okay, so for problem A, you have x squared plus 2x plus 1 equals 0. You know that your A is equal to 1, your B is equal to 2, and your C is equal to 1. So we just plug that into our b squared minus 4ac. So b squared minus 4ac, that would give us 2 squared minus 4 times 1 times 1, which is 4 minus 4, which is 0. Okay. So remember, whenever it's 0, it's just going to be one repeated solution. So when b squared minus 4ac equals 0, you have one real repeated solution. Okay. Any questions on that one? All right, so for question B, we do the exact same thing. We just identify our A, B, and C, and we just plug it in. Okay, so we have 3x squared. And since we don't have an x term, we can make that plus 0x plus 2 equals 0. Kind of just a fill in the blank kind of thing. You don't have to add it, it just makes it a little easier to identify. So your A is equal to 3. Your B is equal to 0. And your C is equal to 2. Okay, so we have our b squared minus 4ac be 0 squared minus 4 times 3 times 2, which is negative 24. Oops, forgot to circle that. Okay. So whenever you have a negative discriminant, you have two complex solutions or imaginary solutions. B squared minus 4ac is negative. you have 2 complex, or either complex or imaginary solutions. Any questions on that one? All right, so for C, move that up a little bit. You have 2x squared minus 7x minus 4 equals 0. We know our A is equal to 2. We know our B is equal to -7. There we go. And our C is equal to -4. All right. And we just plug it in and see what we end up with. So our B squared minus 4AC is going to be -7 squared minus 4 times A times C, so 2 times -4. So we end up with 49 minus 4 and 4 is 16. 16 times 2 is 32. Negative is positive. So plus 32, which gives us 81. Okay. So it's positive. Okay. So when B squared minus 4AC is positive, you have 2 real solutions. All right. So any questions on that one? Okay. Leave that up. I think everyone's done. Okay, so now we're going to look at quadratic functions and their graphs. Uh-oh. Okay, so we know that the shape of quadratic graphs look pretty similar, just various forms of the same shape. Okay, so it's kind of various U shapes. Okay. So let's say, for example, if we wanted to graph f of x equals 3x squared, but you have to start off with just x squared, then we'll go to 3x squared. Okay, so f of x equals just plain old x squared. We have our x and we have our y. It's going to have kind of that look to it. But if we wanted to graph f of x equals 3x squared, So we know that shrinks vertically, or stretches vertically rather. Okay, so that's going to look something like that. Or if we had our f of x equals 1/3 x squared, okay, we know that shrinks vertically. Okay, so that would look something like that, give or take. Okay, so you have your regular x squared, your stretched vertically, and your shrunken vertically x squared. Okay. And let's say even if we had your negative 3x squared. Okay. Remember, whenever you have that negative, it just flips it across the x-axis. So say that's your x, and that's your y-axis there. Okay, so this, let's say this is your regular 3x squared. Then your negative 3x squared is going to look like that. All right, so just kind of different morphs, I guess you can have on x squared. Okay. Okay. So if you have f of x equals ax squared plus bx plus c, it's the same parabola shape to it, but it kind of varies depending on the, I guess you could say, the coefficients of x and your c. So if f of x equals, let's say, ax squared, which is what we've been kind of messing around with so far. Yeah, let's say. The vertex is actually found. Oops. I'll put it underneath it. Let me close that door up a little bit. B divided by 2a. Oh, negative b divided by 2a. F of negative b divided by 2a. Okay. Now for all of these, the lowest point of your graph is your vertex. Okay, so this is your lowest point. Every other value of x is higher than that one. Clean that up. But the difference is with this one is that your vertex is now your highest point because every value of x is lower than that one. Oh, bring that up a little bit. I'll do these examples later. All right. Oh, saw a few people still writing. All right, so we're going to kind of use that to come up with a few general ideas for parabolas. Okay. So the vertex is the maximum value when a is less than 0. Okay, so if you have a parabola where a is less than 0, remember, it's a negative coefficient, so it's going to flip over. So it's going to look like this. So this is going to be your vertex. Okay. Same way we had our negative 3x squared. When it's flipped over, that vertex is the highest point on that graph. But when you have just a regular positive coefficient of x squared, it's the maximum value. When a is greater than 0. And remember, we're just thinking about the ax squared plus bx plus c. So that's the a we're talking about. Yes?
Would it be the minimum value? Or?
Nope, it would be the maximum. Because if you think about the, let's say, if you look at the graph, because remember when you have an x squared, it flips over. So if it flips over, you now have a parabola that looks like that. So this means your a is less than 0. So let's say if it's negative 2x squared plus 3x plus 4, or something like that.
Oh, I meant the second one.
Oh, I completely missed that one. Thank you. I thought you were talking in general. All right. So when a is greater than 0, it's the minimum value. Okay, so this would be your vertex here. Okay, or once again, just using your ax squared plus bx plus c, you get your x value is negative b divided by 2a. And your y value would just be plugging in whatever that x value is. Okay. So just like before, you find the x-intercept for making your y equal 0. Or in this case, f of x equals 0. And you're going to find your y-intercepts by making your x equal 0. Now the axis of symmetry is just your x value of your vertex. Oh, why'd I do that? Okay. So if you figured out the x value for your vertex, you have automatically figured out your axis of symmetry. And all that is that if you have your vertex, if you cut it right through that vertex, it's symmetric on both sides. So that's just going to be your x value. So if you get this one and you cut it right through the middle, that's why the x is your axis of symmetry. It's just if you cut it right into half, it'll be symmetric on both sides. Okay. Any questions on that one? All right. Make sure. Okay, so let's say a few people finish up. All right. So let's say, for example, say for f of x equals 2x squared, clean that up some, minus 4x minus 1. Let's say if we want to find the vertex, minimum and maximum value, and axis of symmetry. Okay. So the first thing we want to do is find our vertex. To be honest, our vertex will help us solve everything around there. Okay, so for 2x squared minus 4x minus 1, we know our a is equal to 2. Our b is equal to negative 4. And our c is equal to negative 1. All right, so once we have that, we know our vertex x value is negative b over 2a. So here we just plug it in. Okay, so you have negative 4 over 2a, which is 2 times 2. Okay, so that's positive 4 over 4, which is just 1. Okay, so now to get our y value, we just plug in our x value. So that's f of negative b over 2a, which in this case is f of 1, which is 2 times 1 squared minus 4 times 1 minus 1. Okay, so 2 times 1 is 2, minus 4 is negative 2, negative 3. So that means your vertex is 1, negative 3. Okay, so that one thing will tell us the other two. Because remember, your x value of your vertex is your axis of symmetry. And this, because we know, since, let's say, 2x squared minus 4x minus 1, we know from this one that a is greater than 0. So we know when a is greater than 0, our graph is going to go up. We may not know the exact shape, but we know it's going to have that upswing to it. Okay, so just doing that, we know that our vertex will be our minimum value. So that means this, so f of x equals -3 is our minimum value. Okay, so the vertex kind of tells us the other two. So once you figure out the vertex, the other two kind of fall into place. All right. So any questions on this one? All right. Let me find a good example. There you go. Still writing. All right. Okay, so just from that previous discussion, let's say we know the vertex can be found using, remember your x is -b over 2a, and your y value is f of -b over 2a. Just plugging it in. But that's only when it's in the form ax squared plus bx plus c, well, not even plus c equals 0. F of x equals that. There you go. But actually, if we use that and we kind of completed the square on that formula, we won't actually go through the steps. If we complete the square, we actually have the form. Quadratic. Form f of x equals a times x minus h squared plus k. And in